All right, make sure calculator in degree mode, and you'll use yours on the test tomorrow. You have one that's allowed. So, if I'm starting here, pictures are very important. On the test, I will say on certain questions, answer using significant digits. If I don't tell you significant digits, you can just do 3 to 4 decimal places. But I'll tell you when I want them. So we have a boat traveling on a course north 37.1 degrees west for 79.5 miles. So if you're going to do bearing, you need a point north-south line. That's my starting point. From here, I'm going to go north, west. And that is 37 degrees, 10 minutes. Okay, and this distance is 79.5. If I want to know how many miles north and west we've traveled, what we could do is just turn this into a right triangle. That would be a right angle. That picture is a little, not the best picture I've drawn, but the north will be this side. So from here, that's adjacent and hypotenuse. So we would say cosine 37 degrees, 10 minutes equals my north over my hypotenuse, 79.5. So now we just use our calculator, 79.5 times cosine. And do you remember how to put the minutes and degrees and minutes in your calculator? 37 plus 10 over 60. And if you do that, you get 63.352. If we did significant digits, you would call it 63.4. I didn't specify on this. Then to find west, that's opposite in hypotenuse, so that would be sine 37 degrees, 10 minutes equals the opposite side over hypotenuse. So if you multiply that over, our west is 3.0288. Or if you did significant digits, it would go 48.0. My recording is covering up my school board. Okay, so we have a tree on one side of a river is due west of a rock on the other side. So here's the tree. The tree is on the west. So this is a perfect horizontal line. We have a stake 21 yards north of the rock. So that's my stake. 21 yards, we're assuming due north. From the stake, so if I'm measuring bearing, we have to have a north-south line. So we're talking about the north-south line at the stake. The bearing of the tree is south 18.2 degrees west. So what I just gave you is this angle. How far is it from the rock to the tree? So we know this would be a right angle, so that's opposite and adjacent. So we could say the tangent of 18.2 degrees equals the opposite side x over the adjacent side 21. Multiply that over. .9044 yards. If I'd said significant digits, you would say 6.90.
So if you don't say significant digits, do you not want it in significant
I mean,
digits?
I won't count it wrong if you give them to me anyway, but they're not my favorite, they're not as accurate, so I don't use them on every problem. So we have a 72.5-foot rope from the top of a circus tent pole. Here's our tent pole. We're going to assume it tells you the pole is perpendicular to the ground. So right angle. The rope is coming down and it's anchored to the ground 43.2 feet from the bottom of the pole. The rope was what angle does the rope make with the pole? So we're looking for this angle up here. From there I have opposite and hypotenuse, so that would be sine. So you can say sine theta equals opposite side 43.2 divided by the hypotenuse 72.5. When you are looking for an angle, that's when you do the inverse. So we do second sine. And that gives us 36.5741 degrees. If I had said significant digits, you would have done 36.6 degrees. Okay so far?
Yeah, I just overcomplicated that picture.
Okay. Does that make sense? So a road up a hill makes an angle of 5.1 degrees with the horizontal. So here's my ground. Your road is going up the hill. This is your slanted side. That's your road. The angle it makes with the ground is 5.1 degrees. If the road from the bottom of the hill to the top of the hill is 2.5 miles long, how high is it? For this side. So the height and the ground would be perpendicular. So opposite and hypotenuse would be sine. So sine of 5.1 degrees equals x over 2.5. So multiply that over. And we get 0.2222. Uh-huh. Whoops. We only had 2, so 0.22. It always starts with the first non-zero digit. Alright. A boat leaves the harbor entrance and travels 25 miles in the direction north 42 degrees east. If I give you a bearing, you need a north-south line and a starting point. So here's where I'm starting. I'm going northeast. So this is 42 degrees. My distance is 25 miles. The captain then turns the boat 90 degrees and travels another 18 miles in the direction south 48 degrees east. So if I'm giving you another bearing, you need a north-south line. I'm telling you from this point you're going southeast. So the 48 degrees is how far from the north-south line? And we know this is 18 miles. But actually, the main part that we need right there is he turns the boat 90 degrees, which means this whole angle is a right angle. We want to know how far is it from the harbor entrance. We're just looking for this side. So we have two sides in a right triangle. That means to get the third one, we could just do Pythagorean theorem. 18 squared is 25 squared equals x squared. I said significant digits, so that means go ahead and give me the decimal. You don't have to break down your radical. So that one comes out to be 30.8058. There were only two significant digits in the problem, so we would call it 31 miles. so the nice thing about that, because I told you in the problem it's the right triangle, we just could do our Pythagorean theorem. Alright, so 22, we have two guy wires from the top of a 35-foot tent pole. We have a pole, 35 feet tall, anchored to the ground below by two stakes. The tent pole is perpendicular to the ground, right angle, and between the two stakes. The stakes are on each side. If the angle of depression from the top of the pole to each of the stakes, angle of depression, elevation and depression are measured from a horizontal line. We're at the top of the pole, so a horizontal line at the top, coming down. So one of these is 47, one of them is 43. How far apart are the stakes? So essentially what we have to do is two separate triangles here. Because the whole triangle isn't a right triangle, but if I take the one on the left and one on the right, those are. So if I wanted to find A, I could say 90 minus 47 is 43. So opposite and adjacent would be tangent. Tangent of 43 degrees equals A over 35. Do that, side A is 32.638. Over here, 90 minus 43 is 47. So tangent of 47 degrees equals opposite over adjacent. Side B is 37.52 or 329. And so the total distance apart, if you do A plus B, and so that gives us 70.1709. I said significant digits, so two significant digits would be 70 feet. Is that okay? Just a couple more words. Angle of elevation of the sun. So elevation starts at a horizontal line and is going up for elevation. So that is 75 degrees, 30 minutes. How tall is a post that casts a shadow 1.5 feet long? Okay, so I have the angle. My post would be this side. And I know the shadow would be on the ground. So opposite, adjacent, that would be tangent. Tangent. 75 plus 30 over 60. So we get 5.8 feet. This one, I'm talking about isosceles triangle. So an isosceles triangle is not a right triangle. Or it doesn't have to be. I just know that two sides are the same. The altitude is the height. And that forms a right angle with the ground. The two equal angles, those are here. Those are both 17 degrees. How long are the equal sides? So if I just take half of this, that would give me a right triangle. So essentially, you don't even need the whole thing, we just need this. So opposite and hypotenuse would be the sine, 17 degrees, goes 25 over x. Multiply over your x, and you have to divide, so 25 divided by the sine, 17 degrees. And that gives us 85.5, but I said significant digits, there were only 2 in the problem, so that would be 86. Do we need to go over any more of the word problems? So let's jump up here. When I ask you to find the exact values, that is your hand trick. Quadrants and reference angles are going to be the work that I want to see. Now, if you don't have an angle between 0 or 360, we need to find the coterm. To do that, if it's a negative, you add 360. If it's bigger than 360, we subtract it. So this is the tangent of 60 degrees. I know 60 degrees is in quadrant 1, everything's positive in quadrant 1. So our hand trick, tangent square root of the top over square root of the bottom. So we just get radical 3. So 315, which quadrant is that? Referencing. This is where I'm seeing most people making their mistakes. Reference angle is distance from the x-axis. So if this is 315, to find our reference angle, you do 360 minus that, so we get 45. If we think about all students take calculus, the reason we do the quadrant is so we know if it's positive or negative. In quadrant 4, cosine's positive, so sine is negative. Then I'm doing my hand trick, so 45 sine is the square root of the top over 2, so it's negative radical 2 over 2. Negative because of the quadrant, the radical 2 over 2 because the reference angle is 45. So this one, if we add 360, that gives us 240. So 240 is in quadrant 3. I can stop right here. In quadrant 3, tangent's positive, so that means cosecant is going to be a negative. Reference angle is distance to the x-axis, so 240 minus 180 is 60 degrees. Cosecant is the reciprocal of sine. So sine at 60 is radical 3 over 2. Cosecant would flip it, so 2 over radical 3, or negative 2 radical 3. And the last one, so if we work through all this, 120 is in quadrant 2. Reference angle 180 minus 120 is 60. So in quadrant 2, tangent's negative. Tangent is 60. Radical 3 over radical 1 is radical 3. Okay, 150 is quadrant 2. Reference angle 180 minus 150 is 30. So in quadrant 2, sine is positive. Sine of 30 is 1/2. Cosine of 180. So that's kind of like a reference angle of 0. We know over here cosine is a negative. Cosine of 0 is radical 4 over 2 or 1. So this is negative 1. So negative radical 3 squared is 3. 1/2 squared is 1/4. So we get 6 minus 3/4 minus 1. So 23. exact values, that's the hand trick. Make sure you're thinking about your quadrant, no positive and negative. I did it like a 0, but maybe the easier option is to go back. Remember in chapter 1 we used x, y, and r. And so this is the point, -1 and 0, r is always 1. So cosine is x over r. Then we had finding all missing parts to our triangles. So, in right triangle ABC, I would recommend drawing a picture on every question. Biggest mistake I've seen on these is labeling them wrong. Side A is across from angle A, and B is 104. So easiest way to get C would be Pythagorean theorem. A squared B squared equals C squared. So we square root. And let's just match significant digits on this. So that comes out to be 124.258, or significant digits. We had 3 given in the problem, so that would be 124. The angles, we could do a trig function from angle A. 68 is opposite, 104 is adjacent. So tangent of A equals opposite over adjacent. Remember, if you want an angle, that's when you do the inverse, so that second tangent. Do that, A turns out to be 33.2 degrees, and so then to get B you could do 90 minus 33.2, so 56.8 degrees.
I put it into degree and minutes.
Oh.
I don't know how you-
Yep, that is totally fine. So if you did that, 33 point. So if you took your decimal times 60, you could have, this is 33 degrees, 10.7. So if you did significant digits, you would round it to 10 minutes, because 11 minutes is technically 4 significant digits. But if I didn't say that, 11 minutes would be correct. And same thing with the 56. If you did that, it's going to come out to 56 degrees, 50 minutes. But if you didn't do significant digits, if you did rounding, it would be like 49 minutes. So side B is 305. Angle B 24.9. So easiest thing to find would be angle of A. 90 minus 24.9 gives us 65.1 degrees. If I wanted to find side C, that's opposite and hypotenuse, so that would be sine. So sine of 24.9 equals 305 over C. So you multiply over the C and then divide, so 305 divided by sine of 24.9. If we match significant digits, there were 3 in the problem, so that would make it 724. If you didn't, it would be like 724.4039. And then you have options for side A. You could do Pythagorean theorem or another trig function. Either way, I did a trig function from here. That's adjacent and opposite, so I might do tangent 4.9 equals 305 over A. So you multiply by your A, divide by your tangent. you're doing significant digits. That's 657, but you could have had decimals. Is that okay? Last one of these, it had degrees and minutes, so just making sure we know how to do that. Doesn't really change anything. Except if I give you one angle in degrees and minutes, that's how I would prefer the next one. So if this is 35 degrees, 30 minutes. Side C is 0.462. So to get B, we have to do 90 minus 35, 30. So this is like 89 degrees, 60 minutes. So if you subtract those, 89 minus 35, so we get 54 degrees, 30 minutes. And then set up trig functions. So we can say the sine of 35 degrees, 30 minutes is a over 0.462. Multiply that over. Okay, 3 significant digits, so if you match it, it would be 0.268. You could do Pythagorean theorem or another trig function to get B, so we might do cosine. And if we do significant digits, it's 0.376. Are those okay? These were calculator questions, so just making sure you know how to plug them in your calculator. If I give you degrees and minutes, you do 24 plus 20 over 60, and we should get 0.4120. Cosine 37.8 should give you 0.7902. For
Just want 4.
yeah, that's fine. You don't have to give me any more. To do cotangent, you have to do 1 divided by tangent. 71 plus 20 over 60. And that should give us 0.3378. Now 11 and 12, if you're looking for an angle, that's when you have to do the inverse. So the only way to separate the sine from the angle is to do that sine to the -1. That's what we do when we're looking for an angle. So I do my second sine. 465. And I get 71.1735 degrees. To do secant, first we have to realize this means cosine is 1 over 1.923. You have to do that before you do the inverse, because otherwise it just gives you an error on your calculator. Then to find your angle, you do cosine inverse of 1 over 1.923. And that gives us 58.6664. So inverses if you're looking for an angle. Yeah, I didn't make it through the whole thing. These, I'm looking for exact values again. So if you gave me something without radicals, it would be counted wrong. This is back to our hand trick. So sine of 45 degrees, we know the pattern for sine, it's always a square root over 2. So do your 45, that's radical 2 over 2. Cosine of 30, so if I fold in my 30, cosine square root of the bottom over 2, so radical 3 over 2. So if I square that, I get 2 over 4 plus 3 over 4 5 over. For tangent and cotangent, tangent is square root of the top over square root of the bottom. So for 45, it's radical 2 over radical 2, which just turns into 1. Cotangent is that thing flipped, so still 1. And 1 plus 1 is 2. Sine of 60, so sine is the square root over 2. So if you fold in your 60, sine is the top, so radical 3 over 2 squared. Cosine of 30 is the square root of the bottom, squared. So you get 3/4 minus 3/4, or 0. Number 7 is 1 divided by. Okay, cosecant is the reciprocal of sine. So if I think about sine of 30 is 1/2. So cosecant would flip it and it would just be 2. So 1 over 2. Cofunctions. I am probably going to put a fill in the blank one like this on the test. I may not even give you the other function. I might just say sine of 14 degrees equals what? So what you need to remember with cofunctions, sine and cosine go together. Tangent and cotangent. Secant and cosecant. And they're equal when their angles are complementary. So the cofunction of sine is cosine. The complement, 90 minus 14, is 76 degrees. So you just have to do 90 minus your angle. And the last one. So we have ABC. And C is the right angle. Side A is 1, side B is 2. You have to find side C, exact values. So 1 squared equals 2 squared equals C squared. So side C is the square root of 5. So sine of A, from angle A, opposite over hypotenuse, 1 over the square root of 5 would turn into radical 5 over 5. Cosine of A, adjacent over hypotenuse, 2 over the square root of 5 is 2 radical 5 over 5. Tangent of A, opposite over adjacent, 1/2. Then I also asked for B's. So sine of B, opposite over hypotenuse, so 2 over the square root of 5, or 2 radical 5 over 5. Cosine of B, adjacent over hypotenuse, 1 over the square root of 5, or radical 5 over 5. And tangent of B, opposite over adjacent, 2 over 1 is 2. So find your missing side, then do your trig functions. So same thing here. C is the hypotenuse, that's 6. B is 3. So to find A squared plus 3 squared equals 6 squared. So A is 5. Oh, what did I do? Yeah, because I subtracted 11 and not 9. About 27. And if you do the square root, that can break into 9 and 3, so 3 radical 3. So, sine of A, opposite, 3 radical 3 over hypotenuse, is radical 3 over 2. adjacent over hypotenuse, 3 over 6 is 1/2. Tangent of A, opposite over adjacent is radical 3. Sine of B is going to be 1/2. Cosine of B, you'd have 3 radical 3 over 6, so radical 3 over 2. And tangent of B is 3 over 3 radical 3. So you get the radical off the bottom and it turns into radical 3. Do I need to work that one out? So tangent of B, opposite side is 3, adjacent is 3 radical 3. So those 3's drop and it's 1 over the square root of 3. So then if you multiply top and bottom by square root of 3, you get the square root of 3 over 3. Another thing that will be on the test, and I've told you guys this, but the table will be on there. So what I'm going to have you do is you have to fill this out, and then you can, without a calculator, and then you can do the rest of the test. This is your hand trick. It would also really help you. You'll have this in front of you when you get to those problems where you're doing like sine of 225 degrees, so you can look back at this if you need to. But remember, when we are going through these, the patterns. And there's a blank one up here on my desk. If you want one, you can grab it. Sine is square root of the top over 2. Cosine, square root of the bottom over 2. Tangent, square root of top over square root of bottom. And then your reciprocals. The reciprocal of sine is cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. So if I'm saying 0 degrees, so if I fold in my 0, sine, I have no fingers above, so square root of 0 over 2 is 0. If I want to go ahead and do cosine, square root of the bottom, so square root of 4 is 2, divided by 2 is 1. Tangent, square root of the top over square root of the bottom, so square root of 0 over square root of 4 is 0. If I do 30, sine, square root of the top over 2, so that's square root of 1 over 2, which is 1/2. Cosine, square root of the bottom over 2. Tangent, square root of the top over square root of the bottom. So radical 1 over radical 3. But if you get that radical off the bottom, that turns into square root of 3 over 3. 45. Sine, square root of the top over 2. So square root of 2 divided by 2. Cosine, square root of the bottom over 2. Tangent, square root of the top over square root of the bottom. So radical 2 over radical 2 is 1. 60, sine, square root of the top over 2. Cosine, square root of the bottom. So square root of 1 is 1 over 2. Tangent, radical 3 over radical 1 is just radical 3. And 90, sine, square root of the top, so square root of 4 is 2, divided by 2 is 1. Cosine is the bottom, square root of 0 divided by 2 is 0. Tangent, square root of 4 over square root of 0 is undefined. And remember, sine and cosine are cofunctions. So the sine of 0 is equal to the cosine of 90. Sine of 30 is cosine of 60. Sine 45, cosine 45. Sine 60, cosine 30. Sine 90, cosine 0. They're just the same reversed. Cosecant is a reciprocal of sine, so reciprocal of 0 is undefined. Reciprocal of 1/2 is 2. If you have the square root of 2 over 2, if you flip that, multiply your radical, Those cancel and you just get the square root of 2. Square root of 3 over 2. So when you flip it, 2 over radical 3, it's 2 radical 3 over 3. And reciprocal of 1 is still 1. And if you remember cofunctions, secant, you could either do the reciprocal of all your cosines or just do your cosecant in reverse. So it's going to be undefined 2 radical 2, 2 radical 3 over 3, and 1. Cotangent, you can do 2 ways. You can do reciprocal of tangent, or they are cofunctions. So it's just your tangent reversed. So a couple different ways to get that.